So the examples so far all yielded very nice clean solutions and can be factorized. So for example, x squared plus 4x minus 21 equals to 0. In this particular case, we're looking for numbers where we have x something and then x something else equals to 0. We know that these two numbers, if you add them, they have to give you plus 4, and if you multiply them, they give you minus 21. And there are only two possible numbers here, which are positive 7 and negative 3, because when you add them, they give you positive 4, and when you multiply them, they give you negative 21. So x plus 7 equals to 0, or x minus 3 equals to 0. So x here would equal to minus 7, and here x equals to 3. However, there are some other quadratic equations that would resist factorization because their factors may not be nice clean whole numbers or even fractions. And that's when we have to use an alternate method called completing the square. So let's have a look at this example. We have x squared plus 6x plus 1 equals to 0. And I can assure you that there is no combination that you can get out of 1 that will make 6. So what do? That's when we use the method called completing the square. So the first step is that we move the constant term to the other side of the equal sign. So x squared 6x. So to accomplish that, we subtract 1 from both sides. So we end up with x plus 6x equals to minus 1. And now, remember perfect square, x plus a squared equals to x squared plus 2ax plus a squared. And the third term has to be the half of the second term squared. So in this case, 6 is 2a, which means a has to be 3. So half of 6 is 3. And the third term, 3 squared, will be 9. So we add 9 to our answers. So we add 9 here, and we add 9 here. Make sure whatever you do on one side, you have to do to the other side as well. So we end up with x squared plus 6x plus 9 equals to 8. Now we can see that this is just x plus 3 squared equals to 8. Of course, to find what x plus 3 is, we just square root both sides. So we have x plus 3 equals to... One thing to pay attention is that because both positive and negative numbers, when squared, will yield a positive solution. So when you square root a number, you have to account for both possibilities. In this case, both positive square root of 8 and negative square root of 8, when you square it, you yield positive 8. So we just have, now we have x plus 3 equals to positive or negative square root of 8. The next step, normal algebra, we subtract 3 from both sides. So x equals to positive or negative 8 minus 3. What does this mean? It means that x can either equal to positive square root of 8 minus 3, or x can equal to negative square root of 8 minus 3. And that's your two solutions to x. And that's why you can't factorize it. Factorize this one here, because the solutions are not whole numbers. In fact, they are not even fractions, they are thirds. Okay, next example. Along the same vein, we have x squared minus 4x minus 8 equals to 0. Once again, the problem here is that there's nothing coming out of minus 8 that you can manipulate enough to produce a minus 4. So we have to use the completing the square method again. Let's have. So firstly, we have to move the negative 8 to the other side. So we add positive 8 to both sides, and we have x squared minus 4x equals to 8. And once again, in this case, 2a is 4. Say 2a is 4, and negative 4, and a would be negative 2, and negative 2 squared, well, it's just positive 4, so we add 4 to both sides. So we end up with x squared minus 4x plus 4 equals to 12. And as you can see here, it's just x squared minus, so correction, x minus 2 squared equals to 12. And x minus 2 itself would be, we have to square root both sides, which end up with 12, square root of 12. And remember, it can be both positive and negative square root of 12. And once again, we add 2 to both sides. X equals to positive or negative square root of 12 plus 2. And with x equals to either positive square root of 12 plus 2, or x equals to negative square root of 12 plus 2. So here are your two solutions. Now let's have a more complicated example. If you notice, so far all the coefficients of x squared has been 1. Now what if it's larger than 1? What if there's actually a number in front of x squared? Let's have a look. X squared times plus 2x minus 3 equals to 0. As you can see here, perfect squares only work if the coefficient of x squared is 1. So what we can do is that we can divide everything by the coefficient of x squared. So we divide everything by 3. We end up with x squared plus 2 divided by 3 is 2 over 3x, minus 3 divided by 3 is 1. And luckily enough, 0 divided by 3 is still 0. So we can see that it's just the same as the previous two examples. We shift 1 to the other side, we end up with x squared plus 2 over 3x equals to 1. And in this case, 2a is 2 over 3. So what's 1 over 3 then? So, sorry, what's half of 2 over 3? Obviously, 2 over 3 divided by 2 would give us 1 over 3. And in this case, 1 over 3 squared. So 1 over 3 squared. And remember to add it to the other side as well. Okay, so in this case, we will end up with x plus 1 over 3 squared equal to 1 plus 1 over 9, which equals to 10 over 9 really. So x plus 1 over 3 squared equals to 10 over 9. And now square root both sides. X plus 1 over 3 equals to 10 over 9. And either positive or negative 10 over 9. Square root of 10 over 9 anyway. And x equal to positive or negative 10 over 9 minus 1/3, since we're subtracting 1/3 from both sides. And if you want to simplify it further, x equal to positive or negative. Then square root of 9 is obviously 3, so minus 3.